Assalamualaikum class. Okay, for today class we go to the admittance parameter. So admittance parameter is also known as a Y parameter. So we know that when we say admittance parameter, so admittance parameter is always Y, which is Y is always reciprocal to the impedance, which is Y equal to 1 over Z, right? So therefore, from here, we know that Y is also a ratio between your current and the voltage, right? So it's similar with the conductance, guys, in the resistive network, which is and then uh, uh, we know that conductance is always reciprocal to the resistor. So admittance is always reciprocal to the uh, impedance, right? So therefore, in admittance parameter, so we are looking for the value of admittance parameter, which is Y parameter. So therefore, we have 4 Y parameter that we need to look at, which is Y11, Y12, Y21, and Y22. So in order to find all those value, okay, so we are using the metric equation for the Y parameter. So the metric equation for the Y parameter is given by this equation, right? So the admittance parameter describe the current in terms of the voltages. So that's why you have I1, right, equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. So as we know, by elaborating this equation, you can find all those value for the Y parameter. So therefore, in order to find the value of Y11 and also Y21, over here, you need to make sure your V2 equal to 0 volt, right? So in order to ensure your V2 equal to 0 volt, so that's mean we are short circuit the V2, which is output part of the linear network circuit, right? So therefore, when your V2 equal to 0 volt, so we can find the value of Y11 over here. Actually, Y11 will equal to I1 divided by V1, right? When your V2 is equal to 0. Okay. So when our V2 is equal to 0, we also can find value of Y21, which is from here. When your V2 is equal to 0, so Y21 is actually I2 divided by V1 when your V2 is equal to 0, right? So next, okay, so we can find the value of Y21 and also Y22 over here. So in order to find the value of Y21 and also Y12, sorry, and Y22, okay, so we set your V1 equal to 0 volt. So that means we are short circuit the input part of the linear network. So when your V1 equal to 0 over here, so we can find the value of Y12, which is Y12 actually I1 divided by V2 when your V1 is equal to 0. And then Y22 is actually I2 divided by V2, okay, when your V1 is equal to 0. So we know that by elaborating the matrix equation for this admittance parameter, so we can find all those value of the Y parameter. Okay, so all this Y parameter is also known as like say you have Y11, right? Y11 is the admittance seen looking into port 1 when port 2 is shorted. So because we know that from Y11 actually I1 divided by V1, so input current divided by the voltage input voltage, right? So this I1 and I2 is actually the input part. So therefore, Y11 is also known as a input admittance, right? And then Y12, okay, Y12 is actually the ratio between the current at the input and then at the voltage at the output, right? V2 is our output part. So therefore, Y21 is known as a transfer admittance. So it is the ratio of the current at port 1, which is input part, to the voltage at port 2, which is port 2 considered as your output part, right? So this can be achieved when your V1 equal to 0 or your input part is shorted. Alright, so Y21 is actually I2 divided by V1 when your V2 is equal to 0. Okay, this Y21 considered as a transfer impedance, right? So this is the ratio of the current at port 2, right? Output current to the voltage at port 1 when port 2 is shorted. So therefore, Y21, we can say that a transfer impedance between your output current and the input voltage, right? When your output output voltage being shorted, right? So and last one, we have Y22. So Y22 is actually Y2 divided by V2. Both are the input currents and also output voltage, right? So Y22 is known as the output admittance. Looking into port 2, is an output part, so that's why we call it output admittance when your port 1 is shorted. Okay, and then this is how we make a analysis for the uh, for the uh, for the admittance parameter, right? So if you are given a circuit, a linear network circuit, all right, so in order to find the I11 and Y21 value, so what you need to do is actually you need to short circuit the output port, right? So therefore this one, the output part or port 2 being shorted, and then you need to apply or you need to introduce the current source at the input port, right? So why we introduce the current source? Because we know that this is the metric equation. The metric equation, we are looking for the I1 value. So that's why we are using the current value. So that's why we introduce the current source at the input port. Okay. So from there, we know that Y11 can be found by using the ratio between your I1 and V1 when your V2 is short circuit. And then Y21 is I2 divided by V1 when your V2 is equal to 0. Okay, so these steps you need to remember, okay, in order to find the Y parameter, which is Y11 and Y21. Next, we can find Y12 and Y22 parameter, okay, for the linear network by short circuit the input port, right? So when we say short circuit the input port, that means the input voltage will become 0, and then we introduce or we apply the current source at the output port, sorry. So therefore Y12 is I1 divided by V2 when your V1 is equal to 0, and then Y22 is actually I2 divided by V2 when your V1 is equal to 0. Alright, so this is the admittance parameter, the equivalent circuit. So this is how we get the metric equation for the Y parameter. Okay, so similar with the Z parameter, Y parameter also have a reciprocal network. So when I say reciprocal networks, always remember reciprocal network contain no dependent sources. right? So therefore current source and ideal voltmeter connected to the port are interchangeable. Okay, so there's no dependent sources in your circuit. So therefore we can say that for reciprocal network, Y12 is always equal to Y21. So therefore, if you can find the value of Y12, so automatically you can find the value of Y21 because they always have the same value.